Let us look at question number 51 now. Which of the given statements is not true about galvanic cells and electrolytic cells? So if you look at the options given to us, the first option it says redox reaction takes place in both cells. This is correct, students. If you talk about the second statement, the Gibbs free energy for an electrolytic process is positive. This is also correct, students. In an electrolytic cell, a non-spontaneous reaction is made spontaneous by the application of electrical current by means of an external battery. Okay, so let us look at the third statement now. In galvanic cells, oxidation takes place at cathode, whereas in electrolytic cell, oxidation takes place at anode. So this is incorrect, students. Whether it is a galvanic cell or it is an electrolytic cell, oxidation always takes place at the anode. So this is incorrect, students. If you look at the fourth statement which is given to us, a galvanic cell can be made to behave as an electrolytic cell by means of an external battery. This is correct. If the applied potential is of greater magnitude and of opposite polarity, then the galvanic cell can be made to behave as an electrolytic cell. Okay. So for this question, we have to mark the correct option as the third option. Okay. Let us look at the next question now. Question number 52. Consider the given statements. So statement 1, it says alternating current cannot be used to measure the conductance of solution as it changes the composition of the solution. This is incorrect, students. This in fact is the reason of application of alternating current. If we use direct current to measure the conductance, it will cause electrolysis of the solution and it will change the composition. If you look at the second statement now, in the galvanic cell represented as this, KCl cannot be used as an electrolyte in the salt bridge. So if you look at the components present, you can clearly see that there is an Ag plus present. So we know that Ag plus will react with Cl minus to form a precipitate of AgCl, which will hamper in the working of the cell. So the statement is correct. We can clearly see that KCl cannot be used as an electrolyte in the salt bridge. Okay. So the first statement is incorrect, whereas the second statement is correct. So if you look at the options which are given to us, we can clearly see that for this question, we have to mark the second option as the correct answer. Let us look at the next question now. Question number 53. Consider the cell. So we have been given a cell A converting into A2 plus and B3 plus converting into B2 plus. So the EMF of the cell was found to be 2.03 volt at 298 Kelvin. So some electrode potentials have been given to us. So if you look very carefully at the data given, we can clearly see that in the first E0 value, it talks about the oxidation. And if we talk about the second one, it is talking about reduction. So if we talk about the E0 of the cell, so the E0 of the cell has to be calculated by adding both these values. If the value given above were in reduction potential, then we would have subtracted this. But in this case, since it is oxidation potential, so the oxidation potential of the anode has to be added with the reduction potential of the cathode to find the E0 of the cell. So this is going to give us 1.5 plus 0.5, which is equal to 2 volts. Okay. So the E is given to be equal to 2.03 volt. So we have to apply the Nernst equation, and for the application of Nernst equation, we have to find out the cell reactions first. So let us talk about the reaction happening at the anode. So at the anode, the A is converting into A2 plus along with the liberation of 2 electrons. If you talk about the reaction happening at the cathode, we have B3 positive consuming an electron and converting into B2 positive. So in order to balance the electrons, we have to multiply the cathodic reaction by 2. And if we add them, we're going to get A plus 2 times B3 positive, giving us 2 times B2 positive plus A2 positive. So if we talk about the Q of this reaction, the Q will be B2 plus ion concentration whole square into A2 plus ion concentration upon B3 plus ion concentration whole square. Okay. So we can put the values and we can find out the value of Q. So the value of Q shall be equal to B2 plus ion concentration, which is given to be equal to X molar. We have to find out the value of X. So it will be X square into 0.1 upon the concentration of B3 plus ion concentration whole square. So this is 0.1 square. So the Q value comes out to be equal to X square upon 0.1. Okay. So if we now apply the Nernst equation, we have E cell is equal to E naught of cell minus 0.06 upon 2 into log of Q. Okay. We can just substitute the values in this expression. So we have the value of E as 2.03, the value of E naught is 2, the value of log Q we've already found out, it is equal to x square upon 0.1. Okay. So if we simplify this, so this 2 will cancel out this 2 and we'll have 0.03 upon 0.03, there will be a minus sign as well, is equal to log of x square upon 0.1. So it means that the value of log of this value is minus 1, which means that the value inside the log has to be equal to 1 by 10. So x square upon 0.1, so we'll take it to the numerator on the other side, 0.1 upon 10, so this will be equal to 0.01. So if we simplify for the value of x, we can clearly see that the value of x has to be 0.1. So if we look at the options which are given to us, we can clearly see that for this question we have to mark the correct answer as option 4. Let us look at the next question now. Question number 54. The conductivity of 0.1 molar BOH solution is found to be 0.045 Simon centimeter inverse. This solution of BOH is neutralized by 0.1 molar solution of HA. The molar conductivity of the BA solution obtained is found to be 100 Simon centimeter square mole inverse, and it is given that 20% of the salt which is formed, it precipitates. So we have to comment on the value of the conductivity in Simon centimeter inverse of the BA solution. Okay. So if we talk about the neutralization reaction happening in this case, we have 0.1 molar BOH and we have 0.1 molar HA. So if we talk about the salt will be 0.05 molar in concentration, but it is also given to us that the 20% of the salt has been precipitated. So the concentration of the salt in solution is going to be 80 by 100 times this value, which is equal to 0.04, as it is given to us that 20% of the salt, it undergoes precipitation. Okay. So the effective concentration remaining in the solution is 0.04 molar. And the value of lambda m has been given to us, it is 100. So the value of lambda m is equal to 100 Simon centimeter square mole inverse. And we have to comment on the value of kappa. So we know that lambda m is equal to kappa into 1000 by C. So this 1000 has been added here in order to accommodate for the system of units which is being used in this question. Okay. So the value of lambda m is 100. The value of kappa we have to find out. The value of C is 0.04 into 1000. So we can clearly see that the value of kappa will come out to be equal to 4 into 10 to the power minus 3 upon simplification, which is represented correctly in the third option. So students, for question number 54, we have to mark the correct option as option 3. Let us look at the next question now. Question number 55. Consider the given families. So we have been given 4 different crystal families and we have to comment on those families which contain an axial angle which is not equal to 90 degree. So if we talk about the tetragonal one, it has all angles 90. If we talk about the second one, which is the trigonal, in the second one we have all angles equal and not equal to 90 degree. If we talk about the third one, we have monoclinic. In the monoclinic, there is one angle which is not equal to 90 degree. And if we talk about the fourth one, which is the hexagonal one, there also we have one angle which is equal to 120 degree. So if you look at the options which are given to us, we just have to eliminate the first one. In the first one, there is no angle which is not 90 degree. So the other 3 crystal families have at least one angle which is not equal to 90. So for this question, we have to mark the correct option as option 2. Let us look at the next question now.